Welcome to Spring LIB.
Okay, in this problem, you're pushing a sled with your sister up a hill, and the hill has an angle of 21 degrees. And we want to know what force you need to push the sled at if the mass of the person and the sled is 49 kilograms. The coefficient of kinetic friction is 0.100. And we want to do this at a constant velocity. So when you have a constant velocity, acceleration is 0 meters per second squared. So what we need to do is figure out what forces are acting here. So we have the pushing force, which is directed up the hill. We have the friction force, which goes in the opposite direction of motion. And then there's weight, which acts directly down toward the ground. So weight is mg. Now, if we set this up so that the movement is along, we set the x-axis up along the direction of motion. So that would be the positive x-axis is along in the direction of the pushing force, negative x-axis is in the direction of friction. And then that would mean that this angle here between the negative y-axis and the weight is 21 degrees. So that means that our x component of the weight is here, and that is mg sine of theta, and then our y component of the weight is here, and that is mg cosine of theta in this case, where theta is 21 degrees. So what we want to do is use Newton's second law, sum of the forces, or net force, equals mass times acceleration, but we want our acceleration to be 0 and our velocity constant, so in our case this is going to be sum of the forces equals 0. So the sum of our forces, we want these along our x-axis, and these are going to be the pushing force in the positive direction, and then negative friction force, because that's in the opposite direction, and then the x component of the weight, which is also going to be along the negative x-axis, so it's negative, and that's going to be negative mg sine of the angle. So our friction force here is actually going to be mu, the coefficient of friction, kinetic friction, times the weight along the y-axis. So that's going to be mu mg cosine of theta. So let's put this all together. We have the pushing force minus the force of friction, mu mg cosine of theta, minus mg sine of theta, the x component of the weight. And these are all equal to 0 when you put them together. So what we want to do is solve for Fp by just moving the other two forces to the other side. So Fp equals mu mg cosine of theta plus mg sine of theta equals 0. And so now we can just plug in all of the values, and we'll have the value of the pushing force. So we're just going to pull mg out to the front since it's in both of these terms. So that's going to be 49 kilograms times g, of course, is 9.81 meters per second squared. And then we're left with mu 0.100 times cosine 21 degrees plus sine of 21 degrees. Putting this into a calculator, we're going to get that our push force, in order for us to have a constant velocity, is going to be 217 newtons.